Hello everyone. Today I want to talk with you how we build CI/CD observability with OpenTelemetry. And before we dive in, my name is Michael. I'm a senior developer evangelist at GitLab. You can find me online as DNS Michi, which is DNS MICHI, on Twitter, on LinkedIn, Polywork, and also on GitLab.com. Now, thinking about observability and CI/CD, let's start with the DevOps tale and build some bricks together. And one of the things when I started a while ago with CI/CD was we're adding it to a project. We need to onboard the teams. There is some trial and error, and at some point it works. But well, the thing is, it's blocking. Sometimes the pipeline is running and it's running and running and running, and developers are not doing anything or cannot do any code reviews or certain things. And from there, we need to find a way to analyze this. What is going on? Potentially with a manual analysis, so identify the CI/CD pipeline duration, identify the critical path, which is the minimum and the maximum execution time. Maybe there are synchronous dependencies or even asynchronous dependencies which influence the behavior and it doesn't behave the same all the time. And from an external dependency point of view, we might be seeing unit tests which are flaky, network connections are flapping, even build dependencies, containers, and everything else has an influence in inefficient pipelines which are running too long, which are blocking reviews, and so on. Now, in order to understand where we want to go deep is we have continuous integration, then we have continuous delivery and continuous deployment. And there are different ways to really start analyzing what is going on and what is blocking inside the pipeline. One of the challenges is, or the number one challenge, we have different tools. We have graphs, we have logs to look at. Manual analysis is also time consuming. So within an active incident where everything is blocking and developers can't do anything, the DevOps engineers are busy and everyone is on call, this is stressful, and this oftentimes you're overlooking something which can be solved rather easily. On the other side, we might be missing context. So some sort of black box guessing while debugging is required or is needed, and this could lead into the wrong direction, not knowing exactly how to fix it, and even delay the fix, which harms production later on as well. On the other side, we don't see everything. Potentially only those with administrator for root access see all the details, because for security reasons. On the other side, users should be able to fix CI/CD by themselves, which needs a balanced approach in that regard. Another challenge from the tools and specs perspective is what do we actually want to measure in a CI/CD pipeline? One thing is to think about metrics, like numbers and text strings as values, how to store them, how to do retention with them, deleting certain older metrics which we don't need in a high cardinality. It needs scalability, it needs high availability, and so on. Similar thing with logs. Sometimes they are too verbose. How to parse, which needs some pre-processing and post-processing. We need to think about storage because it's not endless and it costs money over time when there's too much logs, and potentially they are not helping when they're too verbose. And from a certain perspective, we also have traces. There's a high entry level to learn, but it's getting better because open source frameworks are in the making, and we get more insight. So there's potentially more insight available. And the third challenge I found is either do it yourself or use existing platform features. Do it yourself with an external integration, or it might be upstream supported. Is there code instrumentation needed? Is there anything we can contribute upstream so that everyone can use them and everyone can contribute? And which tools and platform do we actually use? Is it a ready-to-use platform, or what is the evaluation process in that regard? Now, thinking about observability, with all these platforms and tools and problems, over the past years, we've seen like an overlap of observability. So we used to collect lots of logs and metrics. Distributed tracing became popular with open source specifications. We know that metrics can be aggregated, and we can see that logging is just tracking the changes in the system. Now, what does tracing fit in? Before we dive into, like, observability also is about the knowns and the unknowns, so things we are aware of and understand. And an unknown is, for example, things we are not aware of and do not understand yet. So thinking of this with regards to CI/CD observability is like we monitor the state of our application. That's a fact. That's something we want, we are aware of, and we want to we also understand that. And on the other side, the DNS resolution latency actually delays the CI/CD pipeline runs. This is something we potentially do not know yet. We are not aware of it. We do not understand it yet. At some point, we might discover that DNS is the problem, as always. But in that regard, it's a different way to really like understand the thing. Now, how can we like approach all these challenges with observability within CI/CD, with metrics, logs, and traces? Is there sort of innovation going on? And traces specifically are different to logs. So it's a kind of log, but it provides traces and spans with a start and an end time. There is the possibility to add more metadata into the context. You can add code to the application, so-called instrumentation. And the good thing is there is a common specification now with OpenTelemetry, which also defines its specification. It's a framework, so you need to bring your own backend, your own integration, for example, Jaeger tracing as a storage, Elasticsearch, ClickHouse, or something else. You can even like build your own OpenTelemetry distribution, enriching the distribution with specific plugins, for example, adding Jaeger by default or something else. And it allows to evaluate or just use auto instrumentation, whether this can be used for your use case or not. For our use case with CI/CD observability, we'll check it out in a bit. Just for some tracing history to complete that OpenTelemetry wasn't there before. We had Open Sensors and Open Tracing, different tracers like Zipkin, Jaeger, Datadog, Lightstep, and so on. In 2019, OpenTelemetry merged, or kind of merged, Open Tracing and Open Sensors. The CNCF Tag Observability and the OpenTelemetry project have been founded, and later on in 2021, we had also metrics and log specifications being added next to tracing. OpenTelemetry became a CNCF incubating project, and even though like GA for tracing, which means Open Tracing was officially deprecated. And we can now focus directly on OpenTelemetry and learn how to adopt it. The thing is, with OpenTelemetry, you could be running a collector, or you are running a sidecar container, which allows you to send the traces to. As said, bring your own backend, for example, Jaeger for traces, Prometheus for metrics. And there is a huge ecosystem being developed around client libraries, SDKs, allowing you to do manual instrumentation for compiled binaries like C++, Go, and so on. Or, for example, auto instrumentation. So it's like sitting in between the virtual machine in Java and tracing the calls and things which are useful. This is to be like evaluated if it's useful. This is just a picture from the documentation from OpenTelemetry to visualize how it actually works with the collector service. In the end, it's really useful to understand that I'm bringing my backends, I'm having the OpenTelemetry collector service, and something, or like the application which I'm instrumenting, is sending the data to OpenTelemetry, to the collector, and this is basically the entire magic behind that. Now, when we try to solve all these problems with using the knowledge we have about OpenTelemetry and tracing, how to how to merge that with pipeline efficiency. Like, how can we identify long-running or blocking pipeline jobs? This can be sort of matched or mapped into a trace and spans, because sometimes we have the same patterns. Sometimes they are not. It allows us to identify and see visually immediately what's going on in there. It's also like everything gets executed all the time. So the timeline is full and there is no like breakpoint or something we call fail fast patterns in CI/CD pipelines. You don't need to wait until everything gets executed, just fail as soon as possible, save resources and tell the users that something is not working and they need to fix it. The other thing which is interesting to analyze is like, how long does it take to run apt-get install, external dependencies, Docker pull or container image pulling, maybe even though virtual private networks, VPN, low latency connections, and so on. So what needs to be optimized and how to like analyze that and also visualize that for later analysis and actions. Thinking again of the problems to be solved, if we are looking into observability, the knowns and unknowns, we kind of know that our cloud resources, the costs are exploding. They are at an all-time high. The CI/CD jobs are actually the root cause, which has been like identified already. But in the end, what someone didn't really know is that slow caches like I/O for the CI/CD infrastructure is causing that problem, and network latency in container pools, and potentially DNS, because it's always DNS. No, just kidding. The thing is, like, how could we think of a trace in a CI/CD pipeline? And this is like a continuous lifecycle, a continuous infinite loop, a DevOps loop, for so to speak. The user starts with a commit, then there is a push, a merge request event is being spawned, the CI/CD pipeline starts. Then the resources are being pulled. So we need to start containers, virtual machines, all the resources, storage, things like services being run in the background, databases and whatnot. Then specific context switches happen, like between jobs in the pipeline, dependencies, caches, network. The pipeline finishes. And for GitLab itself, the status and the artifacts are being uploaded to the server. They are linked in the merge request, and the notification events for the user actually happen. And from there, I thought of, hey, how to approach all of this with OpenTelemetry in GitLab and CI/CD pipelines. Now, one of the ideas was to keep it as simple as or as minimal as possible with the OpenTelemetry receiver endpoint, so like the collector defined in CI/CD variables, in environment variables, and we want to instrument the server parts, which are written in Ruby, and the runner parts written in Go, and start adding traces and spans to that. The data gets sent to the OpenTelemetry collector, and the visualization is like just using the Jaeger query UI to really see something in the beginning, and later on integrating everything into the DevOps platform, just to have a single unified view on things when improving CI/CD pipeline efficiency and also observability. Now, how to get there with the basics being implemented or the basics being thought about, what else is going on? And when I first looked at the GitLab architecture, like the server is running the pipeline job queue, and it also receives the results from the executors, which is actually the GitLab runner. It does the job execution. We have custom environments, different executors. Where should we be starting of adding code instrumentation with OpenTelemetry to collect something? Now, thinking about the GitLab server workflow, it's a huge thing, and it's like the surrounding umbrella to everything. So like CI/CD pipeline gets executed. There is a queue. The runner connects using via the REST API, collects the jobs, sends back the job updates in an incremental stream. Later on, uploads the artifacts to the server, like a tarball or a binary package, or even a security report or something like that. The server updates the data in the backend, stores the artifacts, and updates also the dashboards, like vulnerability dashboards, merge request widgets, and so on. So there's a lot of things going on, and this didn't sound as right as possible with like getting started with a minimal change. On the other side, looking at the runner is a standalone binary. It connects to the server and collects jobs. This is something we potentially can simulate with just GitLab.com and executing jobs. When the job is executed, like the run action, we have different executors. On a virtual machine using the shell executor, the Docker executor spawns a container, and the Kubernetes executor runs something in the Kubernetes cluster. We can also add metadata for traces. For example, the executors themselves, the operating system, the platforms, versions, everything which is useful, but keep it as small and minimal as possible. Now, coming back to the architecture, server and runner, where to start? The runner is much more approachable and can be used standalone. And the job duration and the executor context is available inside. So this was my analysis and research approach to say, hey, I'm starting with the runner now and adding OpenTelemetry in there. Now, how to get started with adding something in there into the GitLab runner, which is written in Go. I knew I needed to read the documentation and the example for the OpenTelemetry Go SDK. Adding the libraries to the go.mod file, following the GitLab development guidelines, and learning on the way, and also making mistakes, of course, with adding everything together. I created a dev environment, and this is all documented. So it's just like explaining what we want to do. We're starting locally, we're building the source code, and we have a custom runner configuration which defines the registration and also the local executors which are being used. Then the runner gets registered for GitLab.com SaaS in a specific group and only executes specific tags. So I chose OTel, and the way it's being done is basically to define the tag in the CI/CD jobs, so that the runner will only execute jobs which are tagged specifically to that, which allows to really see that the runner is just executing these jobs which are specifically triggered and not something else. The entire setup which is shown over here on the slides is also like documented in my research project, and it can be automated. So it's pretty straightforward. It needs to be done once, and then we can continue developing. The other thing is to really generate CI/CD jobs which do something and sleep a little bit to really stress the runner. In that regard, is we're using matrix builds in GitLab CI/CD and some templates with extends using the OTel tag, and then running some jobs. This can be triggered manually on the server or on the GitLab.com SaaS group, and helps with moving on. The other thing is like connecting the runner, starting the compiled runner binary after some changes, and triggering the pipelines, and just investigating standard output on the console. This was the most easiest way to really see what's going on. Then I thought of adding a tracer to GitLab to the GitLab runner in Go. I found there is context propagation used for traces in the Go SDK. This is something you need to think about if the current application doesn't make heavy use of that or uses them in a different way. It needs to be considered and understood, maybe just by trial and error as well. The good thing is that the OpenTelemetry Go SDK provides a standard output exporter, which allows you to either print it to the console or save it in a file stream. Later on, I continued with manual code instrumentation and also had my first success. certain to-dos still exist in the code. It's not production ready, but still, it kind of worked. I also made mistakes. So I deferred the uninitialization of the tracer in the same function I was calling, and then I wondered why nothing is happening, because it was immediately destroyed afterwards or closed afterwards. And I thought of, well, how can I trace or log what OpenTelemetry is doing? And so I found some verbosity functions from the default logging, which is super helpful in specific vendor-specific blogs and documentation. This needs to be added to the upstream documentation as well. Planning for some pull requests soon. The other thing is like, okay, now I had traces on the console. How would I be connecting to the OpenTelemetry collector? And one of my boring solutions was, well, just send something over, but don't specify a backend. And I learned that you can use the OpenTelemetry collector just for logging to std out, to the standard output, and set the log level to debug, which allows you to immediately see what is going on. And in a second step, we can add the backend. So it's basically like focusing on making it work on one side, and then later on adding a backend and the front end and so on. So I created my own Docker Compose setup and exported the required variable for the GitLab runner, ran it with the custom configuration, and watched things being done. The other thing, after this worked and the first traces have been logged to standard output, I've initialized the external receiver endpoint, so the OTel exporter for traces. There are different transports available, gRPC and HTTP. For my tests, I kind of needed to disable TLS, which is still going on, so it's insecure. There's no TLS. In future steps, the goal is obviously to add TLS as well. For development purposes, it's sometimes a good idea to really focus on what you want to achieve, and if you're feeling blocked, take a step back and say, okay, first it's insecure, later on we're thinking about added security. Yeah, the merge request is linked in the description. Now at the UI, I made the first success of seeing the runner process being actually executed, even adding some metadata into the event. So it's like adding some log events actually to the traces, which is nice. This is the first step in doing so. It also allows to add more context, like which executor is being provided, which is being used, and so on. This is going to be evaluated. For the research tasks, and this is something coming or to be done in the future, figure out which instrumentation for methods and context is needed, which metadata is already available in the source code, which other parts needs to be added to the GitLab runner, and the performance implications of enabled by default, and doing benchmarks and scalability. This is still an ongoing project. Going back from the runner, which is now the first trace and span being sent to the platform. Now the server is a similar thing to the Go SDK. The GitLab server is written in Ruby, so researching the OpenTelemetry Ruby SDK, figuring out the pipeline execution backend and the queuing, and where to start instrumenting the code. For an MVC, a minimal viable change, it's a good idea to start with pipeline start and end times and job and start and end times to really build out the pipeline path or the timeline path and get going more easily. For the server itself, pipeline execution start and queuing a job, measure the time to execution, like the queued jobs, the queued time for jobs, fetch the results, the time of the execution, maybe the artifact size and number, specific log or trace, job log length and insights, storage updates, front-end fetches, and so on. This is all to be evaluated and not written in stone yet. but still it's interesting. And there is much more to be challenged, because CI/CD variables might be protected or masked, so we need to ensure what we can use in there and reuse that from the runner to the server. The job log snippets might also contain certain context or metadata which is useful in the traces, so figuring out how to kind of copy the logs to the traces. The different executors for Docker, for Buildix, for Podman, Kubernetes and Shell, and the operating system and architecture, so Linux, Unix, Power, ARM, macOS, Darwin, and Windows platforms are different, and the problem with the CI/CD pipeline being blocked could be in specific areas of the operating system, for example. Now, one of the challenges is that the server generates a trace ID, and the runner traces or the runner spans which are being added to that, they define it as a parent trace ID, and this is getting sent back to the server at a certain point and completes everything. So you can visualize the complete CI/CD pipeline with the runner, with the server in one global trace, and this should be the ultimate goal. This is not implemented yet, but from the research it showed to be useful. Now, thinking about observability for DevOps, we also want to customize it. And this is like, maybe we want to extend the configuration language and add some sort of trace keyword, maybe also exporting metrics, allowing the users to customize the CI/CD configuration. On the other side, it might be interesting to provide CI/CD tools, CLI tools for CI/CD, which are automatically configured by environment variables, avoiding too much user configuration. This is also something to be discussed in the linked issue. And the other thing to consider is the deployment. When the deployment is done, observability doesn't start yet. So we are just getting started. Something gets deployed into Kubernetes, a cloud virtual machine, bare metal. We're generating runtime metrics, logs, traces, events, error tracking, and so on. And developers need visibility from the deployment tied into the actual CI/CD pipeline. So when we're debugging any certain regressions, we also need an association with a git tag, a commit, a merge request to really see that this trace correlates with the problem. And there's also an idea to add OpenTelemetry to the GitLab agent for Kubernetes, following this path of a deployment together with CI/CD observability. I've talked quite a lot. There are certain other things to really consider, and this is something to be researched in the future. Is it good to use auto instrumentation or manual instrumentation, like collect the traces automatically? Is this reliable? Can we use, for example, eBPF or something like that? Or should we just define the instrumentation scope, focus on the metadata enrichment we want to control as the maintainers of GitLab Runner and GitLab Server, and also limit the collected data, because this can cause problems in large-scale environments. The other thing we need to consider is security and multi-tenancy. Like, they are providing all the traces and spans and context provide raw system insights. It's good for admin and group owners. But we kind of need to limit the data which is collected, or maybe allow filtering for sensitive environments. The other thing is multi-tenancy based on metadata, maybe using metric tags or trace context metadata to really like build out a query language and do something around that. And the other thing, like CI/CD variables can be overwritten in CI/CD configuration files. Maybe use protected variables for that, or really dedicated variables which are then being set for OpenTelemetry. Specifically for the SaaS platform, should we allow users to specify their own OpenTelemetry endpoints, or using a different solution? We need to think about scaling problems, security problems, and also provide some sort of visualization which works out of the box on the one DevOps platform, or somewhere else where like OpenTelemetry and is running to observe the CI/CD pipelines. Now, the other thing is scaling. next to security, we need to look into whether it should be enabled by default, because when it's enabled by default and collects the data actively, we can analyze it at every time, and it's not needed to really like turn it on and try to reproduce the problem, which normally it can't. But on the other side, the data collection needs to scale in small and large environments. So like performance benchmarks. Is CPU usage memory increased in the implementation? Should it be disabled by default on the embedded hardware? How does it work with the architecture, with collectors, sidecars, deployments and platforms actually? So there are many things to consider until this will be available as a general available feature. And also like when we're running many CI/CD pipelines and jobs, there's massive data collection going on in the background. How to scale that? Maybe the collector is a single point of failure. We need to horizontally use some sharding or high availability or other things, which I haven't checked yet if they exist yet. The backend storage might also be needed to scale with, for example, ClickHouse or Elasticsearch. And again, multi-tenancy and security comes into play into all these scaling considerations, filtering the data away and potentially making it slower. Now, looking a little bit more into the future, OpenTelemetry provides metrics and logs, or like what is coming. Metrics are GA, logs are in draft, and I think they are becoming GA soon. We also need to like think about unifying a way to instrument applications, like creating libraries for ourselves in the lab kit for Go and for Ruby in GitLab. Developers need to learn and adopt, and we also need to figure out whether it makes sense to change from /metrics as an endpoint for Prometheus to OpenTelemetry in the collector. This is something else to consider for everything. Now, enabling this for all the platform and for GitLab.com, SaaS, and for the distribution might need to look, or it needs to be added to the code, to the packages. OpenTelemetry might be integrated into GitLab with OpsTrace by default, using Jaeger for tracing and Prometheus for metrics. The dogfooding idea around is to work or collaborate closely with infrastructure and SRE teams to really figure out what is needed and what can be enabled by default. The first minimal viable change enables collaboration. There are many ideas, so it's what I've been telling you now is not like set in stone. Everyone can contribute, and it's important that we document everything in transparently. What I have learned, what we are learning with development docs, dev environments, and building the foundation for, so that everyone can contribute to the ideas. The feature proposal is linked over here. I've started a new website on gitlab.opentelemetry.love and also provided a changelog with recordings and so on to really get this up to speed, and hopefully at future events or in the coming weeks and months I can provide more updates to the research, and we will see that feature or CI/CD observability in GitLab itself in the future. Here's the latest update, providing the demo as well in the recording, which was a really nice success moment for myself. Yeah, and that's about it. Thanks for your time. Thanks for watching. And I wish you a pleasant rest of your day. Thanks.